Hi everybody, we are going to be getting ready to multiply multi-digit numbers using the standard algorithm. Algorithm pretty much just means a procedure that will get you a specific outcome, and standard pretty much means basic, and you may have seen your parents or someone else using the standard algorithm to multiply. But before we start learning that, it's important that we revisit some of the information that you learned about multiplying multi-digit numbers previously that would lay a strong foundation for learning how to use the standard algorithm. So let's go ahead and revisit. You learned earlier on 3rd and 4th grade that you could use an open area model to multiply. This would represent 2 rows with 3 in each row, and the final product would be 6, right? This open area model was based on all the array work you did when you were much even younger, where you actually saw that there was 2 rows and you could see that there was 3 in each row, and you could count them up and find out that there was 6. So this open area model is related to the arrays that you used to really get an understanding of what you were doing. Then we learned how to use the same open area model to break down harder problems and or multi-digit number problems really, and make them a little more simplified. So if it was 5 times 37, say, we could break down 37 into 30 and 7 more. So instead of having to think about 5 times 37, I can think of 5 groups of 30 and then 5 groups of 7. So 5 times 30 is 150. 5 times 7 is 35. I'll add those partial answers together, and I'll get 185 as my final answer. One of the great things about the open area model is that you can see the actual values you're working with. If I'm thinking about the original problem, which is 5 times 37, and say I was multiplying 5 and I was calling that a 3 instead of a 30, 5 times 3 and I got 15. And then I was like, oh, okay, my final answer is going to be 50. I'm going to add those two together and get 50. If I actually think about the numbers that I was working with, 5 times 37, I'd be alerted to the fact that that's a really unreasonable final product to get. Because if gosh, 2 groups of 37 is already going to be more than 50. So I want to be thinking about the real amounts that I'm really using so I can identify when it's an unreasonable answer. It would make me go back and go, oh, it's not 5 times 3, it's 5 times 30. That sounds more like it. So one of the things that open area is good for is to break multi-digit problems down into simpler parts. And another thing this strategy is good for is to see the actual values that you're working with. I specifically like it for when we're multiplying double-digit numbers, double digit by double digit, because this can get confusing to some people. Let's multiply 42 times 32. And I'm just going to break my 42 down into 40 and then 2 more. That's how many rows I have, or groups. And then the 32 I'll break into 30 in each row and then 2 more in each row. And that will give me several nice simple problems to solve. 40 times 30 is 1,200. 40 times 2 is 80. 2 times 30 is 60. And 2 times 2 is 4. And when I add all of these together, I'll end up getting my final product for the original problem, which was 42 groups of 32 is what I was trying to add up. Okay, so again, kind of breaks it up and makes it simpler and more understandable about the numbers that you're really using. So what I want you to do now is pause the video, try these 2. Let's say I want you to try 36 groups of 42. Try solving that and getting your product using the open area model for some review practice. And then just the only other one I need you to do is 54 groups of 176. Okay, go ahead and stop the video, get your math journal out, solve these, and then turn it back on. Okay, the final product that you should get is 1,512 when you multiply these. And then the final product should be 9,504. If you didn't get those final answers, go back and see where you may have made an error in that. So that's good, the review of the open area model. The next model that we're going to review very quickly is called the partial products strategy, or stacked. We did this as well last year. So let's try 15 times 4. Problem like that. Looks a little bit more traditional, but we still want to see what numbers we're working with. 4 groups of 5. I'm just going to go ahead and write what 4 groups of 5 would be. Then I'm going to multiply 4 groups of 10. That's really 4 times 10, right? And that's going to be 40. Altogether, my answer is going to be 60. So now I know that 15 times 4 is 60. The thing that's different from the standard algorithm, obviously, is that you see the actual values. And I'm calling that a 10 and calling that a 5. I'm actually calling it what its real value is. Let's try another one. Let's try 356 times 12. Let's do that. Okay, in this one, I think I'm gonna, as a demonstration, I think I will make this a different color. So how would we solve this much more complex one using the partial products or stacked method? 2 times 6 is 12. 2 groups of 50 is 100. 2 groups of 300, it's not a 3, it's 300, right? 2 groups of 300 is gonna get me 600, isn't it? So I'm finished counting up the 2 groups of 356, but I still need 10 more groups of this whole amount, right? 12 groups of 356 is 10 groups of this amount, and then 2 more of this whole amount. So now I'm going to multiply 10 times 6 is 60. 10 times 50 is 500. And 10 times 300 is 3,000. And you can use your multiplying using your place value chart whenever I'm having to multiply by tens, hundreds, thousands. Review back to that. So then I can use these partial products. That's the product of 2 times 6. That's the product of the factors 2 times 50. That's the product of 2 groups of 300, and so on. So you have your partial products, and then you add them all up, and you'll end up with your final product. 4,272. Again, just like the open area model, what I really like about this one is that it helps kids really focus on what this value really, really is. If for some reason you were multiplying 10 groups of 356 and you ended up with, I don't know, 422 or something like that. Say at the end you ended up for some smaller number. You should have the wherewithal to think, wow, it was 10 groups of this large amount, 300. There's no way it could only be 422. And that would cause you to kind of circle back and see where the mistake might have happened. And you'll get an accurate answer, right? So I want you to pause the video now and try these two using partial products. Let's just do 35 times 16. Try that with partial products. And let's also try 15 times 128. How about that? Try those two using the partial products method